Hello everybody and welcome to Unacademy classes. My name is Abhishek Mishra, and before starting this class, let me open the chat so that I can interact with you, answer your all the questions that you will be having. So let me do that in a bit. So I will be taking this entire session in English, but we will be using quite simple English, so I don't think that you will be finding that much of difficulty in following that language. But for those of you who are okay with it, let's join me for this 2 hour or so session so that we can discuss some of these important questions and tips and tricks along our whole discussions will be provided by me. So looks like the stream is working very fine, and also I've opened the chat. So let's start the class. So today's class is 20 hardest questions. So I don't think that I can complete whole top 20 of this hardest questions. So in one class. So what I will be doing is I will be completing some of the questions in this class, and then I will be doing the remaining questions in the next class, because I want to discuss all of these questions in quite a bit of detail. So let's start this class. And also the questions that I am going to discuss today in this class are not that much of you can say hard, but for GATE examination they are hard. But if you just see them individually, then you will see that they are just some tricky questions, or some of the questions are lengthy where a lot of calculation is involved, and sometimes thinking out of your regular or out of the box is needed. So let's begin this class without further ado. So first of all, I am going to discuss about or give my introduction. Then I am going to discuss about the Unacademy subscription services, because believe me, you have to be aware of Unacademy subscription, because Unacademy is providing such tools which will help you a lot if you are aware of how to use them and how to just or what are the features in Unacademy. So let me just quickly give you overview of all that, and also I will be sharing with you some special codes or a special code which will come in very handy if you plan on using Unacademy. So I have secured all India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi. I have got good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are listed here: photo editing, video editing, cricket, football, and I like all sorts of games. So since you can see, I have prepared for GATE examination and I am currently teaching it. So over the years, both as a student and as a teacher, I have accumulated a lot of tips, tricks, a lot of information that I should be providing you to avoid mistakes, because I have seen some common mistakes and I know about them. So I will be sharing with you when we do the question. So just keep an eye on that, and let's move forward with this screen. You can see there is a link given in the bottom part of the screen. This link, just go to this link and follow me on unacademy.com. What you can get when you follow me on unacademy.com, you will be getting my exclusive classes that I will be taking first of all there. So that is one thing. I am planning on covering metrology revision, and also so we will be revising there for 1 hour. So I will look into what type of things we can revise in an hour for metrology manufacturing subject, and also CNC programming in manufacturing. So you can just see my schedule. I will be teaching that 10 p.m. Today I will be taking metrology, and tomorrow I will be taking CNC programming. So you can follow me there, so that whenever I go live, even if you don't know the schedule, you can be notified via the Unacademy notification via the app. So follow me on unacademy.com. It is absolutely free to follow me, and the app is also absolutely free. Or you can just go to this website and check out my profile, and there all the notes that I am teaching from, all the PDF that I am teaching from will be just there for you to download. So when you go to unacademy.com, what you will find that there is a code that you have to enter to access the free classes, and also to access the or also to download the notes that are free, and also to take part in quiz competition and stuffs like that are going on right now on the Unacademy app and website, which I will also inform you just in a bit. But the code that is important is ABHIMI. So all capital letters. Use this code to watch free classes and the download free notes and take part in quiz competition. And this code will also have other benefits that I will be pointing out right in this class. So Unacademy app is free to download. Just go to your respective app store and download it. And the interface of this app, the quality of this app, the amount of effort that has gone to make this app is very much, and you can see the effort is very much there by the Unacademy team for making this app, so that the student gets most out of it. And you will see that this app has got everything that you require for online preparation. So I recommend you to download it, and not just download it, then explore the features, and you will find that there are a lot of things that you can get benefit from, and that will help you in your online preparation for GATE examination or any other competitive examination. So have a look in this app. And yes, before moving forward, let me also remind you of the new batches that are going to start on the Unacademy, Evolve and Ascend. So for GATE 2020 and GATE 2023, two batches are starting. For mechanical, 28th December, this batch is starting, so you should buy this now. Why buy this now? Because it is recommended that you should attend these classes live classes. In the live classes, the educator, the teacher, will make his best effort to make you to make interaction with the students watching, and that interaction, that asking of questions by the student, and that clearing of doubts by the educator is going to help you a lot, and is going to be better for both the educator and the student. Why? Because if you are watching recorded session and if you have some doubt, because sometimes it happens that one of the things that you are finding easy, or you are finding hard, might be easy for some other, and vice versa. So it is recommended that you attend classes and clear your doubts on the spot, so that you are not going to waste time and you can move forward with the rest of the things that are there in your syllabus. So attend these classes, interact with teacher, get to know the teacher, and also the teacher gets to know you and can adjust his teachings according to his students or her students. So it is very much recommended. And for example, I always take care that the students that are coming on the Unacademy's website and here on YouTube are having a good time in my class. I'm always asking them if they have any doubts, try them to be more engaged, be more involved in the class. So I think that will help you a lot. And live classes are far better than recorded classes. Recorded classes are for emergency situation, or for those situations which you are which is out of your hand. For example, if a class is not going to happen for several months or several weeks, and you want to get the information now, you can attend those things, or to clear some doubts, or to rewatch a class. But to watch a class for the first time, to know to get to know for the first time a topic, or to read or study a topic for the first time, live classes are the best. So what you will get when you subscribe to Unacademy: daily live classes, live tests and quizzes, structured courses, unlimited access of content. So live classes will be held daily, and you can ask your doubts and answer polls all while the class is going on. And if you attend an Unacademy class by just visiting their website, and some of the free classes are there for you to attend, you can see that the interface, the overall the Unacademy experience is lot different than YouTube video. or YouTube online classes, because YouTube is not specifically designed for this education purposes. YouTube is just a normal video streaming site, but Unacademy is specifically designed by keeping this thing in mind, that it is there for students to learn from. So all the things that are there in Unacademy, you will find that they are enhancing your online education or online preparation, and this goes for same for educators also. I find unacademy.com a lot more, you can say, proper to get my teachings to you because of the tools provided there. And tests are also there, and you will find traditional test which is similar to your GATE exam format, which is must, by the way. But you will also find some of the little quizzes that you can give, and these quizzes are very good because in between of your preparation, you want to just warm yourself up or to keep yourself in touch, and what better way to do some of these quizzes. And these quizzes are there in a very new and innovative way, and you can only get to know that by downloading the app and checking them out by yourself. And structured courses are there. Unlimited access of content are also provided when you subscribe to Unacademy. So new subscription prices is shown in the screen, and these are at the moment very reasonable price, and no cost EMI is available on 6 months and above subscription plan. 10% off code, you can use it, the same code that I have provided for the free classes and notes. It is also can be used here to get this 10% off. And the new discounted prices, which is the minimum price at which you can get an Unacademy subscription for, is shown on the screen. And these prices are very reasonable, because just imagine this, just go to Unacademy's website or app and see the number of educators they are teaching you, or number of educators there are available for you to learn from, and the amount of content, the test series, the quiz competitions, the recorded sessions, the notes. So this whole thing that you are getting, this whole package for this reasonable price. So I think you should totally go for it and start your revision preparation as soon as possible. And by the way, let me tell you a very important thing that you should do to prepare in this time, that is few months before your GATE examination. This is the best time for GATE 2021 students to attend the Unacademy classes, because a lot of revision and crash courses are going on right now, and you should right now do this thing, that attend a revision or crash course and then give test, and from the test, the mistakes that you are making, work on them. So only do these two things. Don't try to learn something new. If it is very important, then you can do that, but if it is not that, you are not finding it that repeated topic, then you should totally go for revision, and then you should go for this test series, all provided in the Unacademy. And this right now, a lot of things, crash courses, revisions are going on, keeping in mind that students might need them, and they totally need them at this moment. So a lot of students, I think, are following this approach, and you should also revise and give tests at this moment. And subscribe to Unacademy, follow or choose one of the plan, and just start your preparation. So this is the iconic subscription price. So previously the subscription prices we saw was for plus subscription type, which is classroom type experience. But if you need more assistance, if you need personalized coach and also personalized test analysis, study planner and things like that, you should go with this iconic plan. Here also no cost EMI is available, and 10% code, which is same, can be used here to get discount. And this is the minimum possible price in which you can get an Unacademy iconic subscription for. And per month prices here are very reasonable. Again, just take a moment and notice the things that you are getting for this price, and you will find it very reasonable, and very much you will find them worth it. So choose a subscription according to your need and according to your budget, and start your preparation. And don't forget to use this code, because this code will give you this extra discount that you very much should avail to save a lot of money when you are purchasing an Unacademy subscription. So that's it for Unacademy subscription discussion, and also introduction of mine. So let's start the class. Let's start doing some of the important and hardest questions for GATE 2021 from the subject thermodynamics. Why we are doing this? Because our main aim is to not achieve something by just doing the hardest things, but to learn to make our concept stronger. And we will see here that this harder questions will teach us a lot, will make our concepts a lot better. So let's start the class. So here is the first question, and again these questions, as I have discussed before, are not that much hard, but you have to think a little bit out of the box here. Assuming that air is a mixture of 21% oxygen and 79% nitrogen by volume. Okay, at room temperature and atmospheric pressure, calculate the entropy of mixing of pure O2 and N2 in joule per mole Kelvin to form air at the same temperature and pressure. So you have to you have this oxygen and nitrogen, and you have to mix them to form air at same temperature and pressure. And while you are, or when you are mixing them, there will be generation of or there will be some changes in entropy, and that entropy you have to find in joule per mole Kelvin. And you have been provided that the air is having this oxygen and nitrogen in 21% for oxygen, 79% for nitrogen. By volume, these percentages are given, and they are in the room temperature initially also, and atmospheric pressure initially also, and after your all things are said and done, they are at the same T and P. So let's start this question. Let's start solving this question. There again, if you want to do this question, if you are watching a recorded session or archive session, what you can do is pause this video, solve this question, then resume it and see what is the discussion that is I am doing, so that you can do that question for yourself. And if you are having some difficulty, you can review the solution. So let's start this question solution. So I will do it here. Assuming that air is a mixture of so it is given. So let's calculate first of all change in entropy for oxygen. So since temperature and pressure are same, so I will just remove the change in entropy formulas temperature terms. So for ideal gas, the temperature terms will be removed, and we will be left with pressure, because oxygen's pressure initially is atmospheric pressure, but final pressure it will be less, because the final pressure of mixture it is atmospheric pressure, not oxygen. The mixture is air, so minus R ln. And let's write here, I have to write here one thing more, but let's write here after, we can write here after this equation. So what is the final pressure of oxygen and what is the initial pressure? And you have to multiply this whole thing by number of moles for oxygen. And since we don't have number of moles right now, we have mole fraction, so that will do it. So we will do it for mole fraction of oxygen, multiply this to get our final answer of change in entropy in joule per mole Kelvin. Number of moles is not given, but we can calculate the mole fraction from the data that is available. So this fraction, mole fraction, is to be multiplied here. So minus R is 8.314, units are joule per mole Kelvin. So these are the exact units which will give us the unit of the change in entropy. And ln, final pressure for oxygen when it is in the mixture, or when it is in the form of air or composition of air. Initial pressure is your atmospheric pressure. So what is atmospheric pressure? Let's take it as P. Final pressure of the air is atmospheric pressure, but for oxygen it will be mole fraction into atmospheric pressure. And what will be the mole fraction for oxygen? For oxygen it will be 0.2 0.21, and here also we will write 0.21, and now we can multiply the whole thing by 0.21 to get this change in entropy in the units, that is this. So here we can find the change in entropy in the discussed unit for oxygen. So it will be ln 0.21 into minus 8.314 into 0.21. So it is coming out to be 2.72. The units are joule per mole Kelvin. So in this question everything is very not that hard, but the thing that you may find something to think out of the box is this multiplication of mole fraction. So if you are not doing this, then you are not going to get the correct answer, because when we are going to get this change in entropy in just joule per Kelvin, we need to multiply with this whole, and we are going to multiply with this mole number of moles of oxygen, not the whole system. Therefore we need total number of moles into mole fraction to get the number of moles of oxygen. So that's why this mole fraction is multiplied there. I hope you are able to follow me why that is done. Now we will do the same for nitrogen. So minus R ln. The final pressure for nitrogen will be mole fraction 0.79 P. So that will give the final pressure of nitrogen. Initial pressure is P only, and we will multiply it with mole fraction, which is 0.79. So this will give us the value of change in entropy for nitrogen gas. So it is coming out to be ln 0.79 into minus 8.314 into 0.79. So let me just tell you the value here. So ln 0.79 into 0.79 into minus 8.314. So it is coming out as 1.55, and the units are joule per mole Kelvin. So what is the change in entropy of mixing this pure oxygen and nitrogens to form air? So change in entropy that we have to provide the answer, this value change in entropy, this is going to equal to delta S for this oxygen and delta S for this nitrogen. So this will be 2.72 plus 1.55, and the units are going to be same, that is for this individual values. So we will get this answer in 2.72. So 4.26 or 27 is coming out to be the value in joule per mole Kelvin, which is the change in entropy or the entropy of mixing of pure oxygen and nitrogen in joule per mole Kelvin to form air at the same pressure and temperature as given for the this individual gases before they were mixed. So I hope this question is very clear to you, and if you want some extra information or if you want to ask something there, you have the time, just go for your doubts, answer them in the comment section, and I will answer your questions, then we will move forward. But again, this question is not that hard, but it is something that you have not encountered yet in your GATE examination, but it is very much from your syllabus. So you can just solve it, learn the things that is there to learn, and then move on, because that is what our main aim is. And by the way, this is not the hardest question in the that I have selected. There are some of the very hard questions that is genuinely, I think, harder. So let's move forward and discuss those questions, but this question is quite also on the hard side, and I hope you have understood it properly. So the next question here will be, I have to draw a piston cylinder arrangement. So let me draw it from my page here that I have in front of me. So let me draw it. So here we will have a piston cylinder arrangement, and for it we have to calculate this heat transfer when the piston is moving 3.5 centimeter. So let me just quickly draw that so that you can solve this question. So it is a simple piston cylinder arrangement, and since one of the piston cylinder plus spring questions has already been asked in your this year's GATE examination, so you should be fully aware of this type of question. So this is your figure. You have this cylinder and piston is there. So this is your cylinder, this is your piston, and this is your spring which is attached to this piston. Now here is vacuum, and here is your piston that I have already told you, and this is your spring with spring constant 15 kilonewton per meter. This is the diameter of, since this is cylinder, so this is a circular cross section and its diameter is this. This is the let's take it as x, the initial height at which this piston is at, and you are providing heat to this system. So this will be your air inside, and you are providing heat to it. That heat transfer you have to find and give the value of, and I think all the things that is given in the figure I have drawn for you to look and provide me the answer. So you have to provide the heat transfer in joule when the piston moves from this initial position by 3.5 centimeter, and then you have to provide the answer. So the piston when moves by 3.5 centimeter, obviously the spring will get compressed, and due to that there will be a spring force, and that spring force will generate some pressure, and that pressure will increase the pressure inside your whole this system of, that is below the piston, air, and therefore you can calculate from that the heat transfer. So I hope you are able to follow what the question is asking, and you can do the question. Little bit of a lengthy side this question is in, but you can obviously do it because it is similar to one of the questions that is asked in your this year's GATE examination. So the students who are watching this session live, if you want to do this question, you can tell me in the comment section, and I can wait for you to do this question. Then I will, after giving some time, for example after giving 2 minutes or 3 minutes, I can discuss what the solution is. So if you want to do this question, you can just write in the chat or in the comment section, just write that you are going to do, and I will just wait in the meantime, and you can just quickly solve it and see if your answer is right or not. So if you are wanting to do this question, just give me a heads up at the comment section. I will wait for 10 seconds, then I will start doing this question, because it is better if you do it on your own. You are going to get most out of it that way. So 10 seconds, just provide me if you are going to do it or not. So I think I should start with the solution. So let's discuss how we have to do this question. So let's draw first of all the PV diagram. So we have to find this heat transfer, and heat transfer will be, to find heat transfer we have to find this by finding the change in internal energy and the work done, and this work done can be calculated from the PV diagram. So let's draw a PV diagram so that we can calculate work done, and this PV diagram that I am currently drawing will be very helpful whenever you encounter this spring piston cylinder questions in thermodynamics. So you have to draw PV diagram to quickly do questions and get this work done, because area under this PV diagrams process will give you the work done. So let's take this as bar because the values are given in bar, and let's take volume in meter cube, but it is given in centimeter cube, but we can change that. So this is initially your piston will be at a, so let me draw this piston cylinder arrangement here also, so that we can look into the figure to solve the question. So this is air, spring constant is 15 kilonewton per meter, and piston, this is piston, let's erase that and make it properly. And here x we have to find. So that is what is given in the question, and the most important thing is this area is vacuum. So it is very important, because if it was atmospheric pressure, then you will have to do this question by some other way. So initially your system will be at this point, so this is 1, and let's say finally it will be at 2. So this distance that the piston is going to move is given by 3.5 centimeter. So this distance is given as 3.5 centimeter, and you have to find now what is going to be the final pressure, because when the piston begins to, so let me check if the stream is working properly or not, because so yeah, let's do this question. So initially your point 1 will be here with some pressure and volume, and now its volume is going to increase and its pressure will also increase because of this spring, that is the external force. And when it reaches this position 2, it will be having this process look like this curve or this straight line that I have drawn, and the area below this curve will give us the work done that is done in the process, and this area is looking like trapezoid, so we will going to use the trapezoid formula to calculate the area. So area here will be the work done. Area of this is equal to work done, and that will be equal to P1 plus P2 divided by 2 into what is the base, it is V2 minus V1. So volume 2, you are given volume 1 and you have to calculate volume 2, so that you can calculate by multiplying this area, that you can calculate by using this 8 centimeter diameter and then multiplying it with the 3.5 distance that the piston is going to make further, and then you can get this. And then you can get this V2 and P2. How to calculate P2? Let's do that. So P2 will be the initial pressure plus increase in pressure due to the spring. So initial pressure is P2 is equal to P1, that is the initial pressure, plus increase in pressure due to spring. So it will be K into X divided by area, and we will also divide it by 1000 because this P1 we are putting it in kilopascal. So that to do that thing, we will have to multiply 1 by 1000 to get the answer in kilopascal. So what is your final pressure coming? It will be K is given 15 into 1000 we will do, and what is X? X is that is further compressed by this 0.035 divided by area, it is pi into 0.08 square and 0.08 square, and then we have to do this divided by 4. So what I will do is to make it better for you that what I am calculating, let's calculate here only, because I thought I should open the calculator in the screen itself, but I think it will be better if I just calculate it here only with my calculator, because that way I can see what are the values that I have to use. So again, the final pressure will be what is the initial pressure? P1, it is 3 bar, so 300 kilopascal, and 300 kilopascal. Then what is this? I have calculated it, but somehow I just pressed the wrong button, so the calculation just got wiped out. So let me just quickly do it again. It will be area 0.08 square divided by 4 into the 1000. So 15,000 divided by answer into 0.035. So it is coming out as 104. The pressure increased due to the spring. So the total pressure will be P1 plus this 104.44. So it will be 404.44 kilopascal your P2. So you know P2, you know P1, you know V1, V2 can be calculated. Let's calculate V2 also. So what will be V2? It will be the V1 plus this increase in pressure, increase in volume. So that increase in volume, let's calculate it right now, and it is going to be equal to pi. I'm going to calculate this in cc, centimeter cube, because we have V1 in centimeter cube only. So pi into 8 square divided by 4 into the 3.5 value, so it is 176 it is coming, and 45 is the value of our V1. So V2 is coming out as 176 plus 45, so 221 centimeter cube. So now the work done can be easily calculated. V2 minus V1, so it is coming out as 176 into 10 to the power minus 6, because we have to write that down in meter cube. Then P1 plus P2, it will be 404.44 plus 300 divided by 2. This will give us the work done. So work done is coming out in joules. It is coming out as 62 joule. So this work done is coming out as 62 joules, and now we have to just find the change in internal energy to get the answer. So we know that P1 V1, P2 V2, we know temperature 1. Let's see if it is given in the question or not. So yes, temperature 1 is also given, and it is given as 20 degrees. So for ideal gas, we know for ideal gases, PV is proportional to T. So this will give us P1 V1 equal to T1, and then we are taking this ratio P2 V2 T2. So from here, temperature 2 will come out as, why we are calculating temperature 2? Because we have to find this change in internal energy, which is mCV delta T. And P1 V1 is your pressure 1 is 300 kilopascals, volume 1 is 45 centimeter cube, and then we have this P2, which is 404.44 kilopascal, volume 2 is 176, and then we have this T1 20 degrees Celsius, but we are not going to put that in as 20 degrees Celsius. Instead we are going to put that as 293 Kelvin. So 293 Kelvin, it will be so it is coming out as, so I think I have to do the calculation one more time. Let's do it. So T2 will be T1, that is 293 into P2 404.44 into 176 divided by 45 divided by 300. So yes, it is coming out quite a big value, but again, since our calculations is correct, so we will not here panic by seeing this big value, because I think this is correct one. It is coming out as 1544.90 kelvins. So what will be the delta U here? That is the change in internal energy. It will be, let's do that here, and let's first of all erase this very bad looking arrow. So delta U will be m CV delta T. What is the mass? Is the mass given? No, it is not given, but we have to find this mass, and we can do that. And let's find this mass here only. So mass will be m R T is equal to PV. So m will be equal to, what is pressure? 300, volume 45, but let's convert this into the meter cube, and R is going to be 0.287, because we have taken this pressure in 300 kilopascal. What is the temperature here? Temperature here is 293 kelvins. So from here we can get mass, which is going to be 300 into 45 into 10 to the power minus 6 divided by 0.287 divided by 293. So it is coming out as 1.605 into 10 to the power minus 4 kgs. So this mass, when you multiply this with CV, which is 718 for air in joule per kg Kelvin, and when you multiply this whole thing with this change in temperature, you will get here the change in internal energy as 144.30 units are joule. So this is your 2, this is your 1. Just add this 1 and this 2 to get this Q, that is the heat transfer which is asked in your question. So since this is expanding, this whole thing is expanding, so your heat transfer is going to be positive. So it will be 144.30 plus 62. So it is coming out as 62 plus 144.30. So it is coming out 206.3, and I think here I have not included something, because the correct answer key right now in front of me, I don't have the solution, but answer key is 252 joule. So let's see what is the error here. So let's see if the calculations are right or not, because the concept right now what I'm seeing is absolutely correct. So V176 V2 is coming out so this is coming out to be correct. The work done is 62 only, and that means we have somehow calculated this temperature change in internal energy wrongly. So let's look into that. It will be 293, and it will be 718. Then what is the mass coming? 1.605. So let's look into mass, if it is correct or not. 3 bar, the volume is initially 45, temperature is this much. So again, that seems to be the correct one, and air it is given, so air it will be 0.287, and pressure is also correct. So now let's calculate the temperature here, because that also seems to be one of the might be one of the factors that this answer is coming like what this is. So yes, I now found out what I did wrong, and that is one of the silly calculation mistake, and you should look forward to this things, notice these things. So when I calculated this, put this V2 here, instead of putting this 2 to 1 centimeter cube, I put 176. I instead put the V2 minus V1. So it is very unique and very silly calculation mistake that I did. So now, ignoring that, let's move, not ignoring that, making it correct, let's calculate the right thing here. So it will be 221 divided by 300 divided by 45. So it is coming out as the temperature is coming out not this, because the concept was very much right. It is coming out as 1939.90 Kelvin. So that means this value will be now changed to the correct one. So it will be minus 293 into 718 into 1.605 into 10 to the power minus 4. So it is coming out as 189.79 joules. So adding this to work done, equation number 2, that is the change in internal energy, and 1 is the work done in this process, we can get the heat transfer from the first law of thermodynamics. So it will come out as 62 plus this thing, so it will be 251.79 joules, and the answer key was given 252. So we are very much near that, and this is the correct answer, 251.79 joules, which will be the heat transfer. So again, this question is not that difficult, but you have to do a lot of things here and there to get to the answer, and it is also testing a lot of things, lot of your concepts. So it is absolutely must do, because if not the whole question, because again this whole question might come, because if you are doing this, it might take some 3 minutes or 2 minutes if you are doing it very fastly, but for normal students 3 or 4 minutes is fine to do this type of question. So this can very much be asked in GATE examination, but if it is not asking, then some part of it can be useful to us, some part of it can be asked as a question. So this is absolutely must do for you. And in this year's GATE exam only, we have encountered one of these spring questions. So again, a very good question, and I hope you understood this very properly. And let's move forward to the next question, the question number 3, where we have to find the work input for a centrifugal pump given below. So there is no figure below, that means I have to draw it right now, and the figure is not that complicated, so I will be done drawing it in under a minute. So let's draw it and let's discuss what is there to be calculated and what is given. So first of all, we have this centrifugal pump arrangement. So again, a very new type of question, because in thermodynamics you are not going to encounter centrifugal pump. So this is your control volume. So this centrifugal pump is, I think, a little bit inclined, so ignore that, that was not intended. And this right here is centrifugal pump, a very simple diagram of that. And this height is 8.5 centimeter, or not 8.5 centimeter, it is 8.5 meter. So look into that, and it will be 2.2 meter. And you have water flowing from it, 0.2, and the inlet, let's take it as 0.1, and water is flowing. And you have to provide some, since this is pump, so this requires work input, and that work input that you have to provide to make this operation, you have to calculate that work input in kilowatts, that is given in the question. Work input in kilowatts is to be calculated here. So some things here also are given. 50 kg per second, the mass flow rate. Pressure at 1 is given as 1 bar. Pressure at 2.2 is given as 4.2 bars. And diameter at 1, D1, is going to be 20 centimeter, which is greater than diameter at 2, that is 10 centimeter. So you have been provided with this whole lot of information to get what? To get this work done. And work done will also be, this question can be also framed as what is the capacity of motor in kilowatt, because capacity of motor means the motor is the one which is driving your centrifugal pump, that is providing the work done. So this, not work done, work input. So this work input is obtained from the motor, and this is provided to centrifugal pump to make this flow occur. And this flow is having mass flow rate of 50 kg per second. P1 is your pressure at 0.1, that is inlet. Pressure at outlet is 4.2 bar, and diameter 1 and diameter at 2 is that is inlet and outlet, is also given in the question for you to use and get the answer. This is get the work done. So I hope you can do this question. Only steady flow energy equation can be used here. And since there is no mention of what is the temperature that is going to, that is at the 0.1 and 2, then therefore we will take this temperature as same, so no temperature change. So work input is to be calculated here. Again, I'm writing it below so that the whole thing can be just there for you to look at in the screen in front of you. So let's do this question here. So solution. we have to use steady flow energy equation, and we will see if we have terms. Why we are using this? Because we have to calculate work input, and to calculate that work input, we first of all, this is pump, so this will not be a closed system, this will be an open system, and there is mass flow rate going on, and the steady flow energy equation will be like this, and it includes this terms that are going to be important in our calculation. So H1, that is enthalpy at 1, and this is specific enthalpy, by the way. We will at last, after finding this in work done in this specific units, we will multiply the mass flow rate to get the answer in kilowatts. So H1 plus velocity at 1 squared divided by 2 plus gz1 plus q, heat transfer. I think there is no heat transfer given in the question, so that will be just assumed to be 0 here. Again, not hard question, but something new, so it is always better to do that. Here is the work control volume that we have to find, and it will be I think appear as negative because work input is going to be provided here. So let me just write here one more thing. P1, since enthalpy here is P1 V1 U1 plus this V1 square divided by 2 plus GZ1 plus Q is equal to H2. So in place of H2 we were writing just like H1. It will be P2 V2 plus U2 plus V2 square divided by 2 plus GZ2 plus work control volume. So what you have right here is this equation, and you have to cancel this Q1 and Q2, because when you because they both are equal, as simple as that, because there is no temperature change, since that is not given in the question. But you have been provided with this and this is specific volume, by the way, and you have been provided with this pressure, which are different, and also what will be specific volume here. Specific volume, since this is water, so specific volume, just remember it is 1 by 1000, and it will be meter cube per kg, that is specific volume for water. And it will not be the mass flow rate or the volumetric flow rate divided or the volumetric flow rate divided by the mass flow rate. That will not be your specific volume, because don't calculate that specific volume using the volumetric flow rate. That was the thing that I was going to tell you, because you might make some of the you might have some confusion there. I totally had the confusion when I was doing this question today in the class. I mistakenly took that. Then one of the students pointed out, sir, there was a specific volume written wrongly. Then I checked it, and it was going to be this different specific volume. That is for water, take it as 1 by 1000, that is 1 by your density. And let's do this question now. So P1 is 1 bar, so it will be 100 kilopascal into this 1 by 1000 plus V1. We don't know the velocity of 1. Now we have to calculate V1, and we know this mass flow rate, so this will give us the volumetric flow rate when we divide this with the density. So this will be 0.05. This is going to be the volumetric flow rate, and it is not given in the question. This is our solution, and it will be meter cube per second. And since we have calculated this Q, then we can find velocity 1, that will be Q divided by pi d1 square divided by 4. So this will be, velocity 1 is going to come out as so it is coming out as 1.59. Units are meter per second. Velocity 2, similarly you can calculate it using this above formula similar to that. So it is coming out as 6.36 meter per second. So 1.59 square divided by 2000. Why I have done 2000? Because here in this question what we need to do, we need to find this whole, we are finding this putting this P1 in kilopascal. So this first value will be in kilojoules, so this will also be in kilojoule if we are going to add it. So that's why this is 2000 that we have divided this 1.59, that is V1 square by. Then Z1 just is equal to 0, because at 1 the elevation will be 0, but at 2 the elevation will be 8.5 plus 2.2 mm, not mm, meter. So Q is going to be 0 because there is no heat transfer that is to be seen given in the question, and P2 will be 420 kilopascal. The volume 2 will be here similar, and V2 will be 6.36 whole square divided by this 2000 again, and now we will have this G as 9.81 into this 2.2 plus 8.5, that will be 10.7. so it will be Z2 elevation will be 10.7, and then we will have to divide this by 1000 to make it into kilojoule, and this work control volume that is needed to find in this question can be calculated from this equation. So let's solve this and find the answer here. So work control volume will be coming out as, then we will, and this is going to be coming out in specific as specific work done or specific work input, because we have not yet multiplied the mass flow rate. So let's calculate this and let's see what is the answer coming out here. So my answer right here is coming out as this is minus, so my answer here is coming out as minus 13.04, and this will be in kilojoule per kg, and we have to find this work input as in kilowatts. So to do that we will simply multiply it with this mass flow rate that is given in the question. So let me check if the calculation is right or not, because I am not sure if it is this only. So this will be 4.32 and it will go here, and this will be point square. So let me check it again, so just to be sure, because I don't have the solution with me, just have the answer key. So let me do that. And if you are watching this live, you can also do this calculation. So yes, somehow I calculated it wrongly by doing this very silly mistake of not using brackets there. So always use brackets in your calculation, because I was finding it a little bit odd, because I also did this question recently today in one of my classes, and the answer was nowhere to be 13 point something. So yes, it is coming out as 0.44. So let's erase this. And when we multiply this with 50, we will get the work input as 22.19 kilowatt. So that is your answer. And just notice one thing here, the work control volume is minus, but we have written this work input by multiplying this work control volume term with this mass flow rate to get this answer in kilowatt. But what we are writing here is work input as positive value, not negative. We are not writing the negative value there because the negative value is not going to be considered when we are saying work input, because work input itself means that work is going to be given, and when we are using that in so our equations, for example, is work, if work input is given as 22.19, then the equation, steady flow energy equation that is written in the screen here, in terms of the work control volume, we will write minus 22.19. But when we are saying work input, that means the minus sign is already obvious, and we are not going to provide extra minus sign. So work input 22.19, work control volume, if you are putting that in this equation, put the minus sign in this work input, then solve the equation. So that will be the answer here. Again, a very nice question, and you may say it was a little bit of on the tougher side, but still it is not the hardest question that we have in the class. And here is one of the question that I think is a lot harder than what we have discussed today. And we will, after this, we will have this question, which is again I did it here in the classes, but I think this is also one of the hardest questions you can find, because not hard because for some of the things that you are not usually encountering, so this question becomes hard if we consider that. Otherwise this is a very easy one if you are familiar, or if you are very well versed with your whole concept. And then we have again this question that I did in some of my previous revision classes, so not hard again, but you have to be very careful about the things. And one of the things that here you need to be considering, I have talked about it in this very class, so you can obviously do this question very easily. Then we have this question which is again not on the lot harder side. Here you have to calculate one or two things, then steady flow energy equation, after using that you can calculate the answer easily. Then we have this question where we have this spring piston question that we did one of these questions in today's class. And we also have this other question where we are going to use Clausius-Clapeyron equation and get this question's answer. So these are the questions that I have planned to do this in class, but let's see, I don't want this class to extend over 2 hours, so let's see how much we can do. And so we still have about 50 minutes for this class, so we will try to do this whole thing in this class only. So let's read this question and solve it here. So what is given in the question is an air compressor, and this question, by the way, Let me provide you information here. So let me just so yes, let's do this question, quite big question, so I hope you are ready. An air compressor rapidly fills a 0.28 meter cube tank, initially containing air at 21 degrees Celsius 1 bar, with air drawn from the atmosphere at 21 degrees Celsius 1 bar. During filling, this equation PV raised to the power 1.4 is equal to constant is followed. Find the work input required to double the amount of gas in the tank. So this is a question where we are encountering this filling. So this is unsteady. This question is a unsteady energy equation question, not a steady energy equation can be used here. So we will look into this type of question also, and you will have your all doubts cleared in this unsteady energy equation concept. And I hope all doubts are cleared, because we will going to do this question by using a lot of those concepts. So let's start this class. So let's start this question, I should say. So let's start the solution by, so what we need here, we need to calculate the work input required to double the amount of gas in the tank. So work input is to be calculated here, and that work input is calculated when we are going to make this gas that is present in the tank from M to 2M. So for this question, first we are provided with this 0.28 meter cube tank, and here we have to calculate first of all what is the mass present here. So it will be this, since this 0.28 meter cube is given as the volume, so we can use this PV is equal to MRT formula to calculate the volume. So let's do that. Pressure is 100 kilopascal, volume is 0.28 meter cube, M we have to calculate, and this I should write 1 here, and since this is air, so it will be 0.287, and we will also have here temperature, which will be 294 Kelvin. So from here the mass initially is coming out as, so it is coming out as 0.332 approximately, and it will be in kg. So this is the mass, and it is given that mass after this whole filling process is completed. So it is given, it's given that mass after filling, it will be M2 is equal to 2 times of M1, so it will be 0.664 kg. And since this is unsteady process, so we will have this rate of change of mass in our control volume dmcv by dt as nothing but mass, that is mass flow rate in and mass that is exiting. So this will be because the mass is only coming out, no mass is going to be exited here. So this unsteady flow equation will only give us this rate of change of mass as the mass that is entering, mass that is you can say input. So it will be m dot mi. So now the unsteady flow energy equation, I hope you are familiar with this equation. It is rate of change of this internal energy in the control volume with time is equal to m dot I h I plus q minus m dot E h E minus work control volume. And this will whole be the dot terms because mass flow rate multiplied. So and also this will be in kilowatt, and since this is not given in the question, it will be 0. This is 0, we have already said there is no mass exiting the system. And this we have to find, since this is minus sign because here we are using a compressor, so it should be obvious that this work control volume here is in the form that is shown in the equation. So this equation will be now. So if you guys have any of the problem here, you can ask me. I am seeing the comment section right now and waiting for any questions if you have, because I am going through this question very quickly. So if you have any doubts, you can answer that here. So it is just I am writing the one that we have calculated in the top. So if we integrate this whole thing, we can write this equation as change in internal energy of the control volume equal to m dot, or not m dot I, because that will be when rate of change of this thing will give us just the change in the mass of the control volume, and hi initial enthalpy and work done in the control volume. That dot will be now erased because we have multiplied with this time term and then integrated it. So this will be your equation, and from this equation you can find the minus work control volume, which will be your work input. So your minus work control volume will nothing be but equal to work input that we have to calculate. So this will be the final internal energy minus initial internal energy minus the change in the mass inside the control volume. So it will be nothing but m2 minus m1, and then we have to multiply this with initial enthalpy so that we can calculate this work input. So this work input is coming by this equation, and I hope we have all the information that we require to find the answer here. So what will be the final internal energy? It will be m2, and this is internal energy CV, and final temperature T2 minus m1 C1 final temperature T1. So this is the first term. Then we are going to minus this with m2 minus m1 into CP Ti or T1. So I hope all the things are here with us. So we have initial temperature, we have this final temperature will be also 21 degrees Celsius. So I think we can find the answer here, and let's see what we require here. M2 is known, CV is known, T2 is known. So T2 is not known. T2 will be changed because initially that is 21 degrees Celsius, but due to this filling there will be some change in this temperature. So what will be the change in temperature? We can calculate that from this equation of ideal gas law. So to find T2 we have to find T2, what we need to do is we need to first find this we will first find this specific volume, and that specific volume will be made equal from the ideal gas law as R T2 divided by P2, and we know the P2 we have to look into if the here if we have this P2 or not. So P2 we can calculate via this equation, PV raised to power 1.4 is equal to constant. So let's calculate all the things here. So V1 will be, the specific volume will be 0.28 divided by the mass, which is 0.332. So it is coming out to be 0.84 and 3 meter cube per kg. Then we have V2, which will be just I think half of it, so 0.28 divided by 0.664. So it will come out as 0.421 meter cube per kg. So from here P2 we need to find. So this P2 can be calculated as this equation that I am using to calculate P2. So it is coming out to be So we have calculated this P2. Now it is calculated in terms of this bar. So now let's use this and calculate the final temperature. So the final temperature T2 will be So it is coming out as 387.26 Kelvin approximately, and that you can use it here and find this final answer. So let's find this final answer. The M2 CV will be, M2 is 0.664 into CV, that is we have to find this final answer in kilojoules, I think, or so work input it is not given, but we will find it in kilojoule. So that will be, M2 will be 0.664 into CV will be 0.718, and what will be the temperature to 387 point this 26 minus 0.332 into 0.718 into T1. What is T1 here? Temperature 1. It is 21 degrees Celsius, so 294, and again minus M2 minus M1 is 0.332 into CP 1.005. What is temperature 1? 294. So it is coming out as 116.45 your work input, and since we have already stated here the minus of control volume is going to be the work input. Work input, if you take put that in the control volume, it will be minus sign, but here I should not write the minus of control volume. Instead I should just write here. So yes, because here I should write plus control volume, and this whole thing will become minus because of this work input being minus. So this will be 16.45, that is calculated by me in kilojoule. So this will be a final work input that is to be found in this question. Very lengthy question, a lot of things we discussed here. So let's quickly go through them one by one so that you can again look into what we have done in this whole question. And I think this is one of those questions which has a lot of things going on. So an air compressor rapidly fills this 0.28 meter cube tank initially containing air at 21 degrees Celsius 1 bar with air drawn from the atmosphere at that same temperature and pressure. PV is equal to 1.4 is equal to constant is followed for this filling process. Unsteady filling is going on, or unsteady flow is going on, and this work input we have to find, which is required to double the amount of gas in the tank. By double I mean, or this question mean, that the mass is going to get doubled. So initially we didn't know the mass of the air that was initially there in this cylinder, not cylinder, this tank. And then we calculated the mass by using this ideal gas law. Then we did that mass double to find the final mass. Then we find out the then we use this unsteady flow equation to find this work input, and to do that we need the temperature T2, and to find that we use this ideal gas law and the equation, or the filling process equation that was given in the question. And after that we calculated the final answer as 16.45 kilojoule. And I hope you can see what is going on in the question, a lot of things, and you can know what are the things and why we are used them to get to the final answer. So I think yes, that will be it for this question. And if you have any solution, any discussion, any doubts, you can ask me. The answer key that I have with me is also showing the similar answer 16.82, and we calculated 16.45. So that is very near, and that will be the correct answer. And yes, that will be it for this question. And let's move forward and do the next question, because again I recommend you to do this question on your own when you just learn this from at your home without watching any class. So you can do this and find this exact answer and look into what are the things that are going on, why we have used a certain thing, how to calculate pressure to, how to calculate then temperature to, and all these things. So that will be it for this question. And now let's move to the next question here. So this question I did in one of my classes. So I will do this question, then we will take a nice little break there. Then we will do this rest of the 4 questions for the day, and then the class will be ended. So this question is not that hard, but there is something out of the box going on, something not usual you are going to encounter in most of the question is here shown, or here asked, or here you have to use. So 1 kg of ethane ideal gas is compressed from 1 bar 30 degrees Celsius according to the law PV is equal to, or PV raised to power 1.2 is equal to constant until the pressure is 6.5 bar. Calculate the heat flow from the cylinder and its direction. Molecular weight of ethane is given, and Cp is also given, and we have to provide the answer in kilojoule per kg. So this question right here, let's solve it. The most important thing that makes this question a little bit on the harder, on the tougher side, or on the trickier side is ethane gas. Usually we see air and we use the values of air to find the answer, but this is ethane gas, and then due to this we will have some things changed, and let's look into that. So 1 kg of ethane gas is given, and it is compressed from this 1 bar according to this law, and the final pressure is 6.5 bar. So this is clearly a polytropic process, and to find the heat flow from the cylinder and its direction, we have to find this Q polytropic. And what better way to find this Q polytropic than to use this Q polytropic equation, and we need the variables or the parameters here to find our answer. So Q polytropic is equal to W polytropic gamma minus N divided by gamma minus 1, and here the Q polytropic is to be found, and W polytropic can be found using this W polytropic equation, that is P1 1 minus P2 V2 divided by N minus 1. We know N, we know P1, we know P2, and looks like we can calculate V1 and then V2 by using this law. So V1 first we will calculate, it is going to be M R T1 divided by P1. So this will give us the value. M is given 1 kg, R, this R is not 0.287 because here we don't have air, it will be 8.314 divided by 30. And remember, this molecular weight unit is gram per mole. It is very important. And if you are using this with the universal gas constant having this kilomole as there in the unit, then you can also use this or if you want to convert this into kg, then you can take this molecular weight as 30 kg per kilomole. So this molecular weight is going to be equal to something in gram per mole, and that will be equal to the same thing in kg per kilomole. So if it is x in this, so this will be also x. So this will be your R, and your T1 is 30 degrees, so it will be 303 Kelvin. What is pressure 1? It is 100 kilopascal. So it is coming out as 0.84. And now we can calculate V2 by using the law that is PV raised to the power 1.2 is equal to constant. So this law will give us this V2. So this V2 is coming out as 0.176. So now let's find the work polytropic. It will be P1 V1 minus P2 V2 divided by n minus 1. So this is coming out to be minus 153.76. And the units will be in kilo joule, and we have to provide the answer in kilojoule per kg, but because the mass is 1, because so therefore if we find it in kilojoule, it will be same, so it is minus. And now you have to simply put this W polytropic and use this gamma minus n divided by gamma minus 1 to get the answer. But here comes a trickier part, which might make you, or which might get your answer wrong if you not are clear in your concept, or if you are just ignoring the thing, or if you are just overlooking it. So this gamma is not equal to, so it is not equal to 1.4. Gamma is the ratio of specific heats at constant pressure and constant volume, and specific heat at constant pressure is given in the question as 1.78, and CV will be 1.78 minus R. What is R? It is 8.314 divided by 30. And you can also take calculate CV as R divided by gamma minus 1, and or you have to don't have to calculate CV, you have to calculate CP. So CP can be calculated from this equation, or not CP, you have to calculate gamma. CP is given, R is given, so this is another equation, but we are going to use this equation and get our gamma. So R is going to be 8.314 divided by 30, so 0.277. So 1.78 minus this answer and 1.78 divided by this thing will give us the value of gamma, which is not equal to 1.14. Instead it is coming out as 1.84. So see, the gamma is not equal to the value 1.4, and if you took that, you can get this answer wrong, and hence I think that this question is very well worth doing to get this concept correct of yours. So gamma is now calculated as the 1.184, and now we can calculate Q polytropic. So Q polytropic will be, here let's calculate that. So Q polytropic will be W polytropic gamma minus n divided by gamma minus 1. So W polytropic is minus 153.76 and gamma minus n, gamma is 1.184 minus 1.2 divided by 1.184 minus 1. So what it will be, so it will give us the answer in, so the answer that is coming out here is equal to 13 point, so it is coming out as 13.37 and it will be coming out in positive value because work polytropic was negative and this term will be negative because gamma is less than n. So this will give us the answer in kilojoule and we have to find this in kilojoule per kg, so just divide with the 1 kg. So our answer is coming out as 13.37, which is the correct as matched by the answer key. So again, very good question, and here are a lot of things you have to learn. First of all, molecular weights unit is gram per mole, or it can also be kilogram per mole, and the values will be 30 sil for both of the two units. The specific heat ratio gamma is not always same for all the gases. It is by the way different for gases, and you can calculate that by dividing Cp and Cv, and that's why it was given in the question. And it was coming out here as 1.184 instead of usual 1.4 for gas, because for air, because gamma for air is Cp by Cv, so it is 1.005 divided by 0.718, and if you do this you will find it to be 1.4. Let me just do it, and it is coming out as 1.399, so 1.4. So that's why we are taking gamma for air, and air is the gas that we usually encounter in this questions. So this question just did some type of just throw a curve ball and give this different gas, and just the process was simple. So I think this question was very worth doing. And now we have 4 questions left for the day, and we will quickly go through this 4 question after taking a very short break. So that 5-minute break we will take, and then we will come and do these questions. So I hope you also get some refreshments and then come back, or just revise the class things that I have taught you in this class, and let's come back after some time. Let's continue and solve the questions that are left for this class that I have planned. And then we will see when we will do the list of the 11 questions planned in this series. So where is my pen? Yes, here it is. So this question, I hope I have turned on the mic. So here it is. It is turned on. So in a constant temperature process, 100 moles of an ideal gas at temperature 300 Kelvin attains a final volume V2. Work input during this process is given and initial volume of the gas approximately satisfies the following relation that we have to find. Again, this question is not that hard. I have done this question multiple times in my classes, but I thought this question should be included in this series because a lot of students did this question wrong, and I think if you are not careful you might also do that wrongly, and the options are also there for you to select the wrong answer. So I will just quickly solve this question and tell you where the students were doing this wrongly. So in a constant temperature process, 100 moles of an ideal gas, so N is given as 100 moles. And since this is constant temperature process, so work done will be equal to C, that is constant, and this C can be calculated in is equal to multiple number of things, or this can be calculated, this constant, in multiple number of ways. So this is ln, and we have here two volumes, so V2 divided by V1, and this will be equal to the work that is going as input. But here what students usually do, they simply, the work input is given as 249.42, so what they do here is simply put 249.42, but this is work input and you are using the formula of work done. So put the minus sign here because work input means work is done on the system, so the minus sign will be there. If you are not using the minus sign, you will get a totally different answer, and that solution or that answer is also, that option is also there in the questions for you to select the wrong option and get the negative marks. So C will be N R bar, that is universal gas constant, into temperature since T is constant, and then we will do this ln V2 by V1 and put this equal to 249.42. Now the other thing that you have to be very careful is R is equal to 8.314 kilojoule. Since you are going to this is in kilojoule, so you are going to write the value of R in kilojoule only. Then R is 8.314 kilojoule Kelvin kilomole. So here it is kilomole. So in place of N you have to write the value in kilomoles, so it will be 0.1 kilomoles. Don't write 100 moles here, then your answer will be wrong. So again ln V2 by V1 you have to find, and let's just calculate it. So you will find that this value N R bar T is going to be equal to 249.42, and that 249.42 is here also as work input, so those two things will get cancelled out and you will be left with ln V2 by V1 equal to -1. So this is going to be thing that you are left with, and if you just remove the log there, then you will be getting this equation V2 by V1 is equal to 1 by E. So you will be getting V1 is equal to EV2. So this is your final relation between V1 and V2. So it is B, and somehow if you didn't include that minus sign in the work input value, then you will get the answer C as the your final calculation or final solution, and that is wrong because work input is in minus sign. So not hard question, but a thing that you have to take very note of, that 249.42 is to be put in minus with the minus sign because it is work input. A power washer is being used to clean the top of a house, and water enters at this 20 degrees Celsius, 1 atmosphere, zero point 0.1 liter per second through 2.5 centimeter hose. A jet of water exit. So this same water exits as this 23 degrees Celsius, 1 atmosphere, 50 meter per second at an elevation of 5 meter. The magnitude of heat transfer is asked. Remember here the magnitude is asked from the power unit to the surrounding. Not magnitude of heat transfer is asked. It is given that the heat transfer that is going to occur from the power unit to the surrounding is 10% of the power input. So we have to determine the heat input, not the heat transfer. Not heat input, power input. So solution. Steady flow energy equation, we will be using that. So steady flow energy equation will be since power is given as input, so I expect this to be coming out as this minus sign because input will mean the control volume is coming out in minus sign, and we are calculating here the specific value of that control volume, and then we will multiply with the mass flow rate, which can be calculated from the information given, and get the final answer of input power. And what is the unit that we have to find that input power in? Let me just inform you. We have to find the input power in kilowatt. So kilowatt is the unit that we have to find the answer in. So it will be WCV will be your H1 minus H2 plus V1 square minus V2 square divided by 2, and let's take it as 2000 because we are going to get this answer in kilojoule per kg, plus this Q minus G Z1 minus Z2 divided by 1000. So this will give us the work control volume. So let's calculate it. We have temperature, two temperatures given, so H1 minus H2 can be easily calculated. The whole thing is discussed for water because water is the fluid that is flowing, and its C to calculate the enthalpy will be 4.18, and the units, it will be in kilojoule, and the rest of the things you can remember for C. And V1 and V2, so V2 is given and we don't know V1, so let's find V1 here. So V1, that is velocity 1, is to be find here in meter per second, and we know that Q is 0.1 liter per second, so 0.1 into 10 to the power minus 3 meter cube per second, and if we divide it by the area, then we can get the velocity 1. So Q divided by area we can calculate by dividing this pi by 4 into 0.025 square. So this will give us the velocity 1 as equal to so it is coming out as 0.2 meter per second. So now we have H1, H2 means to calculate them, V1, V2. Q is the magnitude of heat transfer is 0.1 one of the input power or work input, so that will be, because 10% it is given, so by doing this whole thing, work input should be calculated now as, so h1 minus h2, I should write it here. This will be C water into T1 minus T2. So C will be 4.18 and the temperature difference is 3, but it will be minus, plus V1 square, V1 is 0.2 square minus 50 square, it is already given in the question, divided by 2000, minus 9.81 into Z1 minus Z2 is minus 5, because Z2 is greater than Z1 by this 5, so it will be minus 5 divided by 1000, and this will give us the value of work control volume specific. This will be Q minus and this Q will be 0.1 of this control volume, work done or work input, so this whole thing will be equal to minus 13.74 divided by 0.9, so it will come out as this minus 15.27, but in kilojoule per kg. So when we multiply this with the mass flow rate, we can get the power input, so it will be work control volume into the mass flow rate, which is nothing but 0.1, so just multiply it with 0.1 and we can get the answer in minus 1.53, let's say, kilojoule, or not kilojoule, kilowatt. And since we have to answer what is the input power, so we will not answer it with minus sign, because input itself means the minus will be, or let us write here not input but work control volume, because input means that minus sign should not be written. You have to be very careful when you are writing the answer for input power or input work done, and also using that in your calculation. So the input power for this question is coming out as 1.53 kilowatt. So again, very not that hard question, but certain things you have to be very much taking care here, that what you have to put for water, the values, and how you have to take this heat transfer, which is 10% of the input power in your whole calculation, how do you have to just include that, and the final answer can be calculated as minus 1.53, but don't include the minus sign in your answer, because not power in the control volume is asked, power in input power is asked, so no need to add minus sign. It is understood that 1.53 input power means minus for the control volume. So that will be it for this question's solution, and the answer is coming out to be that only, and it is matching the solution. It is in the answer key, it is coming as 1.54, so I think that will be fine. And let's move on and do the next question here. So for today we have two questions more, and let's first of all do this ninth question, then we will do the eighth question. So a pressure cooker has this lid screwed on tight. A small opening with area 6 mm square is covered with a petcock that can be lifted to let the steam escape. How much mass should the petcock have should to allow the boiling So I have missed the word to allow boiling at 130 degrees Celsius with an outside atmosphere at 100 kilopascal, assuming G to be 10 meter per second square. The heat of vaporization of water is 2260 in kilojoule per kg or 40.8 in kilojoule per mole. And you have been given with this options to select the answer from. And let's solve this question. To solve this question, we need this Clausius-Clapeyron equations relating pressure and temperature for different values. So we have ln, this you have to remember, it is minus delta H vaporization divided by R, which is universal gas constant, and inside the bracket we will have T1, 1 by T1 minus 1 by T2. So from here we know, first of all, for one term of pressure should be known. So pressure will be 1 atmosphere, that is 101.325 kilopascal. And to get this, why we are doing this, let me first explain you. Since we have to calculate the mass which the petcock should have to allow this boiling to take place, so that mass, so let's say P2 is the boiling pressure at 130 degrees Celsius. This should be equal to the atmospheric pressure plus the pressure due to this mass of the petcock. So that will be mg divided by area, and this will give us that mass. So we need this mass as our final answer, and we know this value, we know G. We need this boiling pressure at 130 degrees Celsius for this water. That's why we are using this, and we know when the temperature is boiling point is 100 degrees Celsius. For this temperature is 373 Kelvin or 100 degrees Celsius for this pressure 1 atmosphere. So ln (101.325) P2, we have to calculate the heat of vaporization of water is this, and since we are using the universal gas constant 8.314, which is kilojoule per Kelvin kilomole, so we have to use this value 40.8. And I think you have to remember this also, heat of vaporization, because sometimes it is entirely possible that this value is not given, because this is one of the standard values for you to remember. So remember that heat of vaporization of water, just like the latent heat of fusion, which you also should remember, here heat of vaporization is, that is heat required for this phase change to take place, is 20 to 60 kilojoule per kg, or in kilojoule per mole it is 40.8. so it will be 40.8, and since that is for kilojoule per mole, so we will convert that into kilojoule per kilomole. So it will be 40.8 into this 1000 kilojoule per kilomole. So now you can see that and now yes, one more thing, we have to multiply this with this pressure terms inside the bracket. So this will be 1 by 373 minus 1 by 403, because 130 degrees Celsius into Kelvin will be 403. So 1 divided by 373 minus 1 divided by 403 into 40.8, and the minus sign is very important, so don't forget about that, and it is coming out to be 0.979 in minus, with the minus sign. So I think P2 here can be easily calculated now. we just have to remove this log and get this final answer of ours. So just remove the log and get this final value of P2 as, and if you don't write the minus sign you will get absolutely wrong answer. So just take care that you have included that minus sign. So it is coming out as P2 is coming out, that is the boiling pressure at the 130 °C temperature is coming out as 269.81 kilopascal. So this you have to put this equal to this P infinity plus this term so that you can get the answer. So I am right now doing this here. So here the mass will be simply, the atmospheric pressure is so it is 100, so I should also take it as 100 because it is given in the question that this value is 100. So let's take this whole thing as 100, not the usual 101.325. so this is 100 already given, so we are going to take it that only. If you are taking it by not the thing that is given in the question, then you will be getting wrong answer. So just see how much of a difference it will make. It is 269.81, but now since we are taking it what is given in the question, which should be the way, so minus minus 0.9794, it will be 100 divided by answer, so 266. So it is coming out quite differently, 266.286 kilopascal. So here since if you are putting this in kilopascal, then just remember, if you are putting this in kilopascal, remember to divide this term by 1000 to get this kilopascal unit, so that you can sum that with a term containing kilopascal units. Area is given as 6 mm square, so let's convert it into meter, and now the G is, so it is coming out, let's write it into gram, so because it is given in the gram in the question, and it is coming out 99.77 and in grams. So the correct answer here will be B because it is closest with the answer that we have calculated. And since in the question that was, usually I took it from this question from the NPTEL website, and in the question it was not given what is the heat of vaporization of water was, so I have to just write this value, and maybe the examiner who has selected or just took this question has given this or taken heat of vaporization something other, so just the answer is very near to what the examiner has given the correct answer. So that's why our answer are different, because I think heat of vaporization values of examiner might be different, but still. And here let me see if I have taken G properly or not, because that will also be a factor here. So yes, G is taken by me 10 only, 10 meter per second square only. So 102 grams is the right answer, and we are getting this 99.77 grams, which is obviously going to help us select the right answer. So before ending this class, we have this last question of today left. So let's do it and end this class with this 9 questions. So a 50 kg piston in a cylinder with diameter of 100 mm is loaded with a linear spring, and the outside pressure is 100 kilopascal. The spring exerts no force on the piston when it is at the bottom of the cylinder, and for the state shown, the pressure is 400 kilopascal with the volume 0.4 liter. The valve is open to let some air in, causing the piston to rise 2 centimeter. Find the new pressure, and also you have to assume here that the acceleration due to gravity is 10 meter per second square. So to do this question, you will need a figure so that you can understand what is there in the question. So I will draw this figure very quickly. So you have this piston cylinder arrangement. This is your piston, and here a spring is attached. And this is the outside atmospheric pressure, and this cylinder, the system is connected with a air supply line, and here you have a valve. And inside this we have air, and it is also given this piston is 50 kg. In the mass of this piston is 50 kg, and the diameter is given, and it is also given the outside atmospheric pressure is 100 kilopascal. When the piston is at the bottom of the cylinder, there is no force exerted, so that we can say the force due to the spring constant there will be 0 when it is at the bottom. But when it reaches this, or when it moves in the upward direction, there will be some force coming, some force resisting its motion. And for the state shown, for example, the figure that is shown here, for this figure, the pressure is 400 kilopascal and the volume is 0.4 liters. If the valve is now open to let some air in, causing the piston to rise to 2 centimeter, we have to find for that, or after that rise of 2 centimeter, what will be the new pressure here in this system of ours. And we have to take G 10 meter per second square. Don't take it as 9.81 because you will get a little bit of a different answer. So just taking that assumption and seeing this figure, the new pressure will be the pressure which is initially plus pressure which come now due to the piston moving, or due to the piston compressing this spring, and that due to that compression the new this force will be this new spring force will be generated, that is K delta X, and if we divide it by area, then we can get this pressure which is increased when this piston is moving or rising 2 centimeter. So now you have this value 400 kilopascal. You just have to calculate this value to get the final answer. So it will be obviously coming out more than 400 because you are adding something to 400. Now we don't know the K here. In the question it is not given. The K, the spring constant, is not given. So we have to find the K here, and we have to see what are our in what way we can find that. The values are given to us and we have to just see how to calculate this K. So this 400 kilopascal, which is the pressure initially, is equal to the outside pressure plus the spring constant pressure, or pressure due to the force generated by the spring constant. It will be Kx, here it is X, and this is your diameter. So it will be Kx divided by area into 1000 because we have to get this in kilopascal. And let's see if we have something other. So no, that will be fine. And we also have mass of the piston, which will give us that some extra pressure, so we will include that also. So from here we know this value will be also known, and we can calculate this K. But for that we also need to calculate X, that is what is this X. what is the height the piston has here when the pressure was 400 kilopascal and volume was zero point 0.4 liter. So when the volume was 0 0.4 liter, it means it is 0.4 into 10 to the power minus 3 meter cube. And when we divide this volume by area, we can get the value of x. So that value of x will come out as this volume divided by area. To calculate area, we have the diameter of the piston known to us 100 mm. So let's calculate x in the figure. So it will be 0.4 into 10 to the power minus 3 divided by this area pi into 0.1 square divided by 4, and it is coming out as 0.05. So x is coming out as 0.05 and 09. This was the exact value that I think up to this much of decimal places it will be in meter. And now let's calculate k here. So what will be the k from this equation? 400 minus P naught. P naught in the question is given as 100 kilopascal. In the second line you can see that. So 400 minus P naught minus this pressure due to the weight of the piston or mass of the piston. So it will be 50 cross 10 divided by area. Again, diameter is known to us. So now we have that value, and we can now calculate the k value. So it is coming out a very big value. Let's write it down here. So it is coming out as 58,347,9.604 Newton per meter. Since this is coming out a lot bigger than expected, let's check out if we have done all the things correctly or not. So 50 cross 10, what is area? So yes, it is. It was coming a little bit different initially. So again, I did this question in one of my classes today. So I thought something was off here. So it is coming now as 36,46,7.47 Newton per meter. So now we have to find this final new pressure. So it will be pressure initially, that is 400 plus this term. This term will be K into delta X. Delta X will be 2 centimeter rise, and then we will divide it by area. So that is going to be pi into 0.1 square divided by 4, and since this is in kilopascal, so let's divide here 1000 also. So let's divide multiply here 1000 to make this into kilopascal. So it is 92.86 coming in kilopascal. So your final answer will be 492.86 kilopascal as the new pressure when this piston is rising by 2 centimeter after this valve is open to let some air in. And G is taken as 10 centimeter. If you're not 10 centimeters, sorry, 10 meter per second square. So if your answer is coming out little bit differently, check what have you taken as your G, or some other calculation also you can check. So that's how you can solve this question. So I hope you found this class helpful and engaging, and something you have learned from this class. If you have watching this full class, I think you have I can say that something you should got from this class, and that will help in your GATE examination. So thank you for watching this class. You can follow me on unacademy.com. The link is shown in the screen below, which you can go and follow me. Follow me there, so that all my classes on the unacademy.com are visible to you. All my schedule there are visible to you, and my schedule is visible to you. And also you can download notes, watch free classes of mine there. Some of the classes that I'm taking there are exclusively can be found there only. So just check them out, and use this code when you go to the Unacademy website or app, so that you can watch the classes for free. Not only my class, you can watch other educators class for free also. And this code you can see right here is ABHIMI, and this code is also can be used to join the competitions like Unacademy Combat, where you can win prizes. And 29th of December 6 p.m. one of the combat quiz competitions is going to take place. Second combat quiz competition, where 15 questions will be there, and you can solve them and win prizes according to your rank. Top 100 rankers will be given prizes. What are the prizes? You can see in their website, and register today so that you don't miss that mark. And that's it for today's class. Again, if you found this class helpful, just hit the like button, subscribe to this channel, and also hit the bell icon so that you can get notified whenever I and some other educator goes live, so that you can attend those classes live, which is, by the way, the absolute better way to attend classes. Because if you are watching recorded sessions, I think the whole interaction point will be just not there, and therefore your classes, there will be not that, you will not find the classes a lot helpful. If you are watching it live, it will be very enhanced experience for you. So that's it for today's class. 10% off code is ABHIMI. This time is the best time for subscribing to Unacademy. Why? Because you are going to get this subscription, which is having a lot of revision classes and crash courses going on right now in the Unacademy's website, and you can access those by subscribing, and then just selecting which subject you can learn, and just do the revision classes, watch them, attend them, interact with the educator there, ask your doubts, and then give test series, which is also there with the subscription. And follow this basic thing of follow this approach of giving or doing revision or crash courses classes, and then giving test series and learning from your mistake. And follow this, and also do some of the previous year question papers fully. You can download them from the GATE official website. Do all these things, and I think you will be very well prepared for your GATE examination with a good amount of confidence, because a lot of these things will make you do questions fastly, and very they will cover a lot of your things, because there is no time to go through a lot of lengthy topics, new lengthy topics, which you are just doing for the sake of it. If you are finding the topics which are important, which you have not yet covered, again attend revision classes. Still, if you have some doubts, attend some of the classes from in which you can find that topic, or read through them from a book or from notes provided by Unacademy's educator, or from NPTEL. You can also provide download the notes or view the notes, which is IIT website, and the notes provided are by the IIT educators. So that all thing you can do. So that's it for today's class. If you found this class helpful, again hit the like button and share with your students, and see how many hard questions that they can do. And again, you can pause the question, watch them, do them, and then see the solution that I did. So that's it for today's class. This is 10% off code ABHIMI, and best of luck for your preparation. Thank you for watching. Stay safe and take care. That's it for today's class.